Dear friends, I am happy to welcome you all for this wonderful episode of E5 series lecture. Today, the second lecture will be delivered by Dr. Gajula Prasad. In the present scenario, we know everything is getting energized. The electric vehicles are energized with the help of batteries. But here is a person who says batteries are unwantedly occupying space or the volume, otherwise it increases the weight of a component. So probably if we have nano generators, there is no need of batteries in future. So today we explore an exciting frontier in energy technology, mechanical to electrical energy conversion using Triboelectric Nanogenerator, or which is also known as TENGs. Our guest Dr. Gajula Prasad, who is working as a research professor at Korea Tech University, South Korea, will share how these tiny devices harvest everyday movements and vibrations like walking or fabric motion and turn them into clean, usable electricity. From self-powered wearable electronics to healthcare sensors, IoT devices and environmental monitoring, TENGs could redefine the way we power our world with autonomy, portability and sustainability. Let's dive in and see how the future of energy is literally in motion.
Today I'm going to discuss the talk mechanical to electrical energy conversion via triboelectric nanogenerators for the usage of next generation self-power wearable electronics. Before discussing the topic, so first I would like to say thanks to Dr. Yoganandam. So he is one of the senior, and he is a very interactive with other researchers, and he's encouraging the platform like E5. And I would like to thanks to this giving me the platform to share my thoughts. And I will also say all the best for the future his success in this case in the E5 season. So today we are going to discuss the importance of triboelectric nanogenerators for the mechanical to electrical conversion efficiency. So we know that triboelectric is a word. We can also say the statical charges, static energy, this kind of thing. So if you see the title page, the left side, there was a small kid who is touching some iron pole, and he is getting some shock. So he's getting some shock. So this is common phenomena in almost the winter countries. So many of them experienced, because when we are using some different cloths, and when you are walking or going something, so your cloth is rubbing with your body, and there will be some static charges are well generating. So when you touch some other conductive materials like a iron or some tap or some tables or PC, something, you used to get some shocks. So this is called thermal shocks. So this is thermal shocks is a main origin. So we can say to introduce find out the triboelectricity more. So this is a main concept. So let me discuss the brief outline of the talk today. So first we are going to discuss what is the importance of this study. So that means in this study we are going to discuss what is the importance of mainly the self power wearable electronics, why we want this for the future next generation. So next we are going to discuss the importance of triboelectricity, and after discussing the triboelectricity basic principle, so we are going to discuss what are the factors will affect the triboelectric performance, and we will going to discuss about the what kind of mechanisms will be involved in triboelectric phenomena, and we are going to study the background of the study. So as of now, what are the studies is going improve the performance, and we can also tell finally end with where we can be used in the future. So let's see the first importance of the study. So we know that nowadays all the people is like to love the smart living. So I can say the smart civilization. So because of the smart civilization, usage of wearable electronics are growing rapidly. So including finger to shoes cloths, smart guys, eyes, everything was smart built. There are so many wearable electronics are increasing, so making the modern lifestyle. So we can say the one of the example is healthcare is the most important and significant in wearable electronics apart from the stylish or modern. So here it will be as a you can give it will add a passion to the person, beauty to the person, and also it can recognize the health. So together it is a mutual benefit of the usage of smart wearables. So we can these are however this all the smart wearables is working based on the power. So without power it cannot be work, right? So we should have to see that as of now most of the these wearable electronics are using the super capacitors or function the batteries. So maybe we are recharging batteries, we are recharging and using, or maybe we are using conventional batteries. Once the battery was dying, so we used to replace the new battery. So this is the normal as of now, right? Conventional wearable electronics. So now we are going to move towards the thing batteryless wearable electronics. So I can say why we need a batteryless electronics, right? So we say you can see if it's a battery, so it has some weight, right? The battery will add on a weight for you for wearable thing. So it will is uncomfortable, and also these are the commercial available wearable electronics have using batteries. So with these conventional batteries have a main limitation is limited capacity. That means once the battery was charged fully finished, so it cannot operate the wearable device, right? So suppose you have wristwatch have the battery, what we will do once the battery will finish, so the watch will stop working, right? So similarly you can assume that wherever it is using the commercial available battery based technology, it is a little it is have a drawback. So and we don't know when it will stop also, right? So to avoid this we need a next step, so that is called we need to develop one device. So without battery we can say that is a self power. So without battery means self power. So the device we are going to develop a device, so the device will generate the electricity by itself and it will operate the wearable electronics. This is called self-power wearable electronics. So this is our main motto of for the next generation we are going to give. So for this we are going to discuss about the importance of, now we see the self-power importance, right? So now we have to know what are the self-power techniques are available in the present scenario. You can see that there is nano generators are promising way to address this self power things. So there are many are there, but I'm going to discuss very few nano generators. So first of all, we want to know the word of nano generator. Nano generator is a word itself, it's telling nano plus generator. So it is a small electronic chip, it can generate mechanical energies or any others to small range of nano range of electrical energies by using any of the mechanical or some other physical thing to electrical. So this is called the nano generator. So now see what are the broadly used nano generators means piezoelectric nano generator, pyroelectric nano generator, thermoelectric nano generator, triboelectric nano generator. These are four very famously using. Still we have the electromagnetic many of them, but I'm just going to discuss just these four. So piezoelectric is a piezoelectric. First, we will discuss the piezoelectric. Piezoelectric nanogenerator is a device. It can able to generate the electrical energy by using the physical, mechanical stress or strain. So if you take any piezoelectric material, you apply a mechanical stress or strain like a pushing or pulling, so you can generate some electrical energy. So this is the piezoelectric device. So, but this is have some advantage. What is means all the if you need to use for the piezoelectric nano generator, the material should be actively in piezoelectric. That means any material, if you use stress strain, it should have to respond electrical energy. So that is called piezo selective material. So that kind of materials only you can use. You cannot use all the materials. So next one is pyroelectric. Pyro means heat, right? So pyroelectric is means it is a pyroelectric devices. Nano generators will generate the electricity by using the heating or cooling. So any device you take, heat or cool, it will generate the electricity, means it is becoming a pyroelectric. So thermoelectric is also a similar to the pyroelectric, but here there are, you need to take the two materials as a reference kind of thing, and we have to take the differences between the two materials heating. That called is a thermocouple. You can say that is a similar to thermocouple. So thermocouple means it is a couple of the temperature differences. By using these two differences, we can generate the electricity. It is called thermoelectric. So this above three have common disadvantages, because all the materials cannot be used for the these three generators. Piezo has the own limitation, and pyro thermo also all the limitations. So that means every device should be operate only which the response to this thermoelectric, pyroelectric or piezoelectric, these materials only. But now we are going to discuss the triboelectric. So triboelectric is an exceptional case. Now we are going to case study of this one in it elaboratedly. Let me see the introduction of triboelectricity. Triboelectricity is a Greek word. It is a combination of tribo and electric. Tribo means rubbing. In the Greek meaning, tribo of is rubbing, and electric means electricity. So which means it is giving it is giving that by there is a relation between rubbing and electricity. So I can say very briefly, means when you rub a material, it will generate the electricity. This is a simple, very common phenomenon. Let's see one example. So we know that if any cat, if many of them may be noticed, if any cat or any animal was rubbing with some other material. In case of this example, we can see that a cat was rubbing her skin with the thermo beads, and after that when it get off from the thermo beads, it you can notice that the thermo beads will stick to the cat's wool. So we can see this phenomena. So there is no gum is there, but how the thermo beads are stick to the cat wool, right? So we have a question, right? How it is possible? So for that we used to explain very deeply here. So we can see that this is a new process of charging. So first, initially, the beads and cat wool is a neutral charges. There will be no charges. When the cat rub her skin with the beads, what will be happen? So because of the material electron affinity differences and this one, so what will be happen? One material used to get the positive charge, one material get the negative charge. Now we know that which one is a positive, which one is negative, means in our compared to these two, which is losing electrons and which is gaining electrons, matters. So when lose electrons, it get positive. When gain the electrons, it become negative. It is a common example in chemistry. So if you want to explain more, just see this another example. So I think many of them are also aware of this. We in high school studies we are know that. So when you take a balloon and just directly stick to your human hair, it will not stick. So you just try to rub your balloon with your hair. After some time, you leave your balloon close to the hair. The hair will attract towards the balloon. Okay, this is you should have to understand now what will happen when you rub balloon with your hair. The hair will losing the electrons and balloon gaining the electrons. So ultimately, gaining electron, balloon get the positive charge, negative charge, and the lost electrons of the human hair get the positive charge. So when you bring again close to the human hair, the balloon, the hair's positive negative attraction happen. That's why the hairs are attracted towards the balloon. So this is the best example. I think you can understand very clearly. So you can see this thermoelectric mechanism in a brief. The you can see this one. This pink and blue are the neutral charges. When it rub together, it has the generated the electric positive negative charges. When separating towards the away, so then there is a positive and negative potential differences between the two films, which will leads to induce the electric charges on the yellow color electrodes. So because of this electron moving from top to bottom electrodes or bottom to top electrodes, giving the electricity. So this is the main principle of the triboelectricity. So that means rubbing of the two neutral materials. By rubbing, you are generating the electricity. So this is the basic principle of the triboelectricity. So now we have a question: how much current or how much electricity will be reducing, right? Producing. So it is depends on the amount of charge which generated over the fill-in. So if you are taking a higher higher the electron efficiency differences material, positive and negative, you can use the higher values. So in this case, the what will be the thing was there is a we can say the triboelectric series. Triboelectric series is a tendency series which can make based on the losing and gaining of the electrons by using the tendency. So if you see, this is called triboelectric series. We have ranked some material based on the losing of electrons or gaining electrons. If you say the left one is a positive and right one is negative, so the right one means it is a tendency of gaining the electrons more. Left one is tendency of losing the electrons more. So if you say from the left one steel to the silicon from bottom to the top, the positivity is increasing, which means it is ready to lose the electrons very easily. And similarly, if you see the right side, tribonegativity material, wood to poly Teflon, polytetrafluoroethylene. So this one from top to the bottom, you can use tribonegativity was increasing, which means it is ready to gain the electrons. So for example, I can say that one example: if you take a polyethylene rod and dry with the dry cloth with taking, and you can rub. So, okay, polyethylene rod you are taking and rubbing. What will be happen? Polyethylene is a negative charge and dry cloth will get positive charge because cloth will losing electrons and polyethylene rod will gain the electrons. So you can see the second one, you are using the dry cloth is same, but you are using the instead of polyethylene rod, you are taking Perfex rod. So in case of Perfex rod, you can see that same dry cloth earlier it is getting positive charge, now it is getting negative charge. So the Perfex rod is positive charge. So what the point I'm going to highlight here is the triboelectric is always a phenomena of the both comparison. You can say that relativity. You can say that relativity. You can say, you cannot say which is the positive, which is the negative. See, because if you take dry cloth, if I ask you, dry cloth is a positive material, negative material, means you cannot say, because I should until unless I reveal the another counter material, another counter material. So if I say polyethylene rod dry cloth, which is a positive, which is a negative, you can say dry cloth is a positive. If I say the perfect rod and dry cloth is negative. So you need to know the relativity. So that means you have until unless you don't know the two materials, you cannot say which is a positive or which is a negative. So this is the point I want to say. Now can you see one example here? So can we imagine, now I am just highlighted two, right? Polyimide and polyamide. So which is a positive and which is the negative? Definitely it was ranked in the positive side is polyamide and polyimide is negatively ranked, right? So we can say that it is a positive is a polyamide and polyimide. So another example I can take polyimide and PTFE. So Teflon. So in this case, what happened? Even though these two are ranked in negative materials, so relatively, which is the more tendencies to lose electrons? PTFE is ranking in the series, right? Less. So that's why this is the negative material. Polyimide become a positive material. So now I will ask I can ask a question. If I use these two devices, so polyamide and polyimide one device, polyimide and PTFE one device, and Teflon is another device. I use the two triboelectric nanogenerators and I will generate the electricity. So which one is giving more energy? Because the triboelectric differences of polyamide and polyimide is having higher differences, right? So it is a positive and this is a negative. It will generate the more energy compared to polyimide and poly Teflon. So this is the one example. You can understand how the triboelectric series is working and how to select a material to generate the higher electricity. So which means you have to choose the most maximum electron differences, electron affinity differences of the material to attain the good triboelectric performance or a good electric performance. So now we can see apart from that what is the factors affecting. So we can also see that other factors we can affect nature of materials. So we just now see the nature of materials and applied pressure. So how much is the force you are applying between rubbing, during rubbing, what how much pressure you are applying, that is also matter, can which can also decide the output of your electricity by using the pressure. And also surface textures, like materials have any porous, any roughness, like this also have an important factor which can also decide the output performance of the devices. And also humidity and temperature, these two also major contribution in deciding the electron, this one, if it is a humidity more, the performance will be down. So, and also temperature more, that electricity will also sometimes become low. This depends on the material property, which how it reacted to the temperature. So, but however, these two are the conditions which will affect the performance. These are the broad working mechanisms of TNG. Four methods we can say: contact separation mode, lateral sliding mode, single electrode mode, and freestanding triboelectric mode. So here we can say the first one is a contact separation mode. So contact separation mode is already we explained, here the tribo films are positive and negative films were rubbing in a contact vertical mode. So just it is touching and going. This kind of rubbing is going. So we can see that how it will generating electricity. We already discussed. So this is one example in the video. First video you can see here the vertical contact separation of the two films. You can also generate the electricity, and it can able to glow that 120 LEDs without any additional power sources. So we can see the importance of the TNG while generating the electricity. Another one is a lateral sliding. In the lateral sliding, here the friction materials will slide one over one in a horizontal position. Earlier it is a vertically, now it is a horizontally. So you can see the another example of video how the generation of the vertical, sorry, horizontal lateral sliding mode. So you can see this is one material. Another one was the bottom. So when we rub laterally, so you can able to generate the electricity. So so the next one is a single electrode mode. The single electrode mode also is similar to contact separation mode, but here we are telling the name itself single electrode. Generally, if you use a triboelectric, you need two electrodes and two triboelectric materials. But when you when you remove one triboelectric film and you can sorry, one electrode, then we can use the another one electrode, another one is connected to the ground. So this is called single electrode mode. So the operation is similar to the contact separation mode, only the change is here having the only one electrode compared to that remaining all the working mechanism, everything was same. So instead of the electrode, it will ground was act as another electrode in this case. So whereas in freestanding electric mode, this is similar to the lateral sliding mode, but here the tribofilm, one tribofilm is there, and it have the two electrodes in the bottom which are attached to that film, and another tribofilm just rubbing. That tribofilm doesn't have any electrode. This is also called some single electrode kind of thing mechanism, but the thing is the both the electrodes were attached to the single film in the other direction, friction opposite direction. So this is the basic four methods of operation of TNG to generate the mechanical energy to electrical energy in four different ways of rubbing, either contact separation, freestanding, lateral standing, lateral sliding, or single electrode mode. In out of this, broadly, the contact separation mode is to be frequently to generate the triboelectric generations, because lateral sliding cases, when it is rubbing over the one, so the one of the materials will be taking place and heat also generating, the performance will be decreased in a longer time. So that's why not preferable the lateral sliding modes. Only contact separation modes are using frequently, either single electrode or conventional two electrode system. Any of the thing was people are focusing.
Dear friends, let us continue this video by next week as part 2. In the part 2 video, you will be taught how to enhance the performance of TENG. So it is possible to change the TENG performance by changing the roughness or modifying the surface or hybrid technique. So if you are new to this channel, please subscribe and stay tuned. See you next week.